Good morning, children. Today, let's continue the lesson heat. In the previous few classes, we have studied what is heat, transfer of heat, modes of heat transfer, that is conduction, convection and radiation. And today we will study what are good conductors and bad conductors of heat. Bad conductors are also known as insulators. So the opposite thing for good conductors is insulators. Insulators are also known as bad conductors of heat. In this lesson we will study about heat. So we are considering bad conductors and good conductors of heat. General information for good and bad conductors of heat means when a particular object allows the heat to flow, at that time it is known as the good conductor of heat. For example, when your mother cooks food in kitchen, the utensils which she uses are made up of steel, they are made up of aluminium, etc. When she takes that containers, keeps on the stove or a burner and then lights the burner or the stove, after some time we observe that the container becomes hot. It becomes hot since it allows the heat to pass through that container, through that material, through the utensil. Therefore, they are the good conductors of heat. On the other hand, if you consider a wooden stick, a long wooden stick. This stick has two ends. Suppose one of its end is put into the fire and you are holding the stick at its another end. You will observe that your hand does not get burned. It is because the wood is a bad conductor of heat. Wood does not allow the heat to pass from one end to the other end. Therefore, we are safe in that case. Our hands will not burn. But what about the first condition? In the condition of the container, a steel or aluminium container kept on the stove, we cannot hold it directly with our hand when it is hot. Our hands will get burned. So what does our mother do? Our mother takes pieces of cloths in both of her hands and then with the help of that cloth she lifts the hot containers. So that is because of the heat does not pass through the cloth made up of cotton and therefore the hands are protected. They are not burned. So these all things we will study under the few experiments given in the textbook, page number 61, 62 and 63. Let's understand expansion and contraction of a solid substance due to heat. Under this point, there is one experiment based on a metal ring, a metal ball, a burner, etc. So we require things like metal ring, metal ball, a burner, etc. What we will do in the beginning? We will take the metal ring and the metal ball and we will try to pass the metal ball through that ring. The ball easily passes through the ring. On the other hand, you take the same ball and you hit it on the burner. Hit it for a while, for 2 minutes, 3 minutes and let the ball get heated. After the ball is heated very well, same ball you have to try it to pass it through that given ring. We observe that the ball does not pass through that ring. Why does it happen? It happens because of when solid object, the object which is the good conductor of heat, is heated, it expands. As it expands, the particles which are present inside that ball gets expand and the volume also increases. As the volume increases, the size also increases and therefore as the size of the ball increase, it is not able to pass from the ring which is already given. After that, you let the ball cool down. You keep the ball for cooling. Once the ball is completely cooled down, we observe that if you try to pass this ball through the ring, it will get easily passed. That is because of when the ball cools down, the ball contracts. The particles present in the ball, the metal ball, contracts and it comes back to the original place. The volume reduces down and comes back to its original place, and therefore it is able to pass through the ring. Let's come to know the second experiment, expansion and contraction of liquids due to heat. The first experiment was for the solid state. The second experiment is for the liquid state. This experiment also explains us the same thing. When the object is heated, liquid substance, when it is heated, it will expand, and when it is cooled down, it will again contract. When water is heated, the level of water increases. Same thing we will bring it down in the form of experiment. We need a conical flask, some water, thermometer and a hollow tube. Okay. In this experiment, when water is heated, which is present in the conical flask, so when it is heated, there is rise in water level. This rise in water level takes place due to the heat is provided to the water. When the heat is provided to the water, the molecules, the particles which are present in the water expands. As they expand, there is a gap, or the place present in the two particles is more as compared to the when they are in cold state. So when there is more place between two particles, obviously the volume also increases, and therefore there is rise in level of the water. If this water is cooled, it is brought back to its original state. We observe that the level also again decreases. It happens because of only heat. The level of the water increases when heat is given, and when it is cooled, the level also comes back. The third experiment is for the expansion and contraction of gas due to heat. First we have studied of solid, then we have studied of liquid, and now we will study of the gaseous state. As the heat is given to the gas, it will expand. This experiment can be studied with the help of one balloon. What you have to do? You have to take a balloon, you have to blow the balloon and take it closer to the hot object. You will observe that automatically, without giving external air filling into that balloon more, the balloon becomes bigger. That happens because of the heat is gained to the gas which is present inside the balloon. As the heat is taken inside the balloon for the gas also expands. The distance which is present between the two particles of the gas increases. As the distance increases, the volume also increases. As the layer of the balloon is very thin, obviously it will take heat inside. From the outer surface of the balloon, the heat will be passing to the inner surface of the balloon, and therefore as the distance increases between the two particles of the gas, the volume also increases, and as the volume increases, we will see that the balloon size also increases. So that happens because of heat. When it is brought back to cold stage, we observe that the balloon also loses its size and it comes back to whichever state it was filled with air. Our last point of this lesson is thermos flask. We all have thermos at our homes. Thermos is used for keeping the hot objects which are present in the form of liquid. If you have hot tea or hot water, when you keep the tea which is hot in the thermos, you will see that it remains hot for a longer time. This happens because of the structure of the thermos. A thermos is specially made to keep the hot objects in its temperature for a longer period of time. When you keep the hot objects in the thermos, it remains hot for about 4 to 5 hours in the same temperature. Why does it happen? It happens because of the special structure of the thermos. How is it built? The thermos has two tubes into it, fitted into the thermos, in such a way that there is a gap between the two tubes, and that gap has no medium. It is made up of vacuum. As it is vacuum, there is no medium to pass for the heat. The heat which is present inside the thermos, for example hot tea or hot water, heat is present. Yes, so when that has no medium to pass from inside the thermos to the outside the thermos, the environment present outside the thermos, as it has no medium to pass the heat, therefore the heat remains into the thermos for longer period of time. But though it is having vacuum state inside the thermos between the two tubes, still it remains for 4 to 5 hours or 8 hours. After that it will come back, it will cool down. Why does it happen? Though it has vacuum, but still thermos has a mouth opening through which there is a gap, there is a cavity between the thermos bottle and the cap of the thermos. So there is a gap through which heat can pass, heat can leak through that, and therefore after few hours we see that the hot object, the hot tea or the hot water cools down after some time. Here we finish up with the lesson heat. Thank you.